Welcome to Exponents and Exponential Notation. The goals of this video will be to express repeated multiplication using exponents and also to evaluate expressions in exponential notation. Exponential notation or exponential form is commonly found in algebraic terms, expressions, and equations. Exponents are used to shorten or condense repeated multiplication. Here's an example. 3 times itself 5 times is equal to 3 to the power of 5, or 3 to the 5th. The term 3 to the 5th is written using exponential notation. 3 is the base and 5 is the exponent. The exponent or power indicates the number of times that the factor or base is multiplied together. So notice how here we have an exponent of 5 and we have 5 factors of 3. In general, for any natural number n, b to the nth power, or b to the power of n, means b times itself n times. So there will be n factors of b. Here are several examples of exponential notation. This first one states, if there is no exponent given, it is to the first power. Here we have x to the second power, or x squared. Here we have x to the third power, or x cubed, x to the fourth power, and so on. I want to spend a moment discussing why we often call x to the second power x squared and why we call x to the third power x cubed. Well, it's based upon some geometric formulas. Here we have a square where all sides have length x. So the area of this square would be x times x, or x to the second power. Again, you can see why it's often called x squared. It gives the area to a square. Here we have a cube where each edge has length x. So to find the volume of this cube, we would find the product of x times x times x, which would be x to the third power. So x to the third power gives the volume of a cube, hence the wording x cubed. Let's go ahead and put this into practice. Write in exponential notation. We know that our factor is 2, so our base will be 2. And the question is, how many factors of 2 do we have? And we can count these. Looks like there's 7 of them, so it's 2 to the 7th power, or sometimes just 2 to the 7th. This next example, notice how all of these factors are not the same. We have 2 factors of m and 4 factors of n. So in exponential form, we would have m to the second power, m squared, and n to the fourth power. So the reason I threw this one in here is we have to make sure that our bases or the factors are the same before we attach an exponent to condense. So now let's take a look at some expressions written in exponential form. Let's evaluate them. So if we want to evaluate 4 squared, our base is 4 and we're going to multiply it by itself twice, or have 2 factors of 4. Of course, 4 times 4 is 16. Here on number 2 we have negative 3 in parentheses and we're squaring that. So we would have negative 3 times negative 3. Well, we know that a negative times a negative would be positive 9. Now in this next question we have to be careful. There are no parentheses around the negative 3. So one way to think of this would be the opposite of positive 3 squared. The key here is that this exponent is attached to the positive 3. It's not attached to the negative 3 like it was in number 2. So this would look like an opposite, or the negative positive 3 times positive 3. So this would be equal to negative 9, not positive 9. It is important that we do recognize the difference between number 2 and number 3. On number 4, 4y raised to the third power. Again, notice that 4y is in parentheses. So 4y is our factor that's being multiplied times itself 3 times, or we have 3 factors of 4y. 4 times 4 times 4, that would give us 64. Of course, y times y times y would give us y to the power of 3. I hope that helps explain use of exponents and also how to evaluate expressions written in exponential notation. Thank you for watching. The next video will deal with order of operations.